So you all, I think everybody, it's probably safe to assume that everybody in this room knows that we're in a pretty significant drought in California. Now we have, this building is kind of unique in who we have working here, so we all get exposed to this kind of information. But what's maybe not that easy to do is to put everything together as to what, to build the picture, because it's pretty complicated. And if we look at, how do we get into this drought? Well, you can see there's a lot of year-to-year variability in California for precipitation. So if you look at the Sacramento River unimpaired runoff since 1906, that's considering what the runoff would be if we didn't have all the dams in place and everything. Then you can see we got big years and little years, and there's really, here if you look at the average here, there's really not very many years that you get an average amount of precipitation. So you get your average by having a lot of big years and small years, and looking at the long-term average of that whole thing. So we have these periodic droughts. You can see in the 1970s, it was kind of a short drought, but there was one there. There was one in the early 90s, and then we're currently in this one sort of a protracted drought with some breaks for the last several years here. If you look at how this translates into stream flow right now, we've got some of the lowest stream flows on record in a lot of locations. They're definitely in the lowest 10%, lower than the 10th percentile. They've had some rain recently in the LA basin, so some of those streams are up, and then there's reservoir releases in places that complicate things a bit. But most places are really running very, very low. And if you look at our precipitation since October last year, you can see, we've had some precipitation, quite a bit, 40, 50 inches up in the mountains of Northern California. Even in the valley here, showing the green, 10, 15 inches. Not so much down in the southern part of the state. So when you look at where people get their water from in Southern California, I think most folks in the room also know they get most of their water not from Southern California, right? They get it from Northern California, from the Southern Sierra, from the Colorado Rockies, and they get some locally, but they don't have a lot of reservoir storage in Southern California. So not getting the precipitation down there doesn't impact them as much. So I guess you could say they're diversified in their supply. So how does this look compared to normal for precipitation? Well, there's some pretty significant deficits there. You look at all this deep red, that's 15, 20 inches or more of precipitation that we haven't gotten since the beginning of the water year, which started October 1st. And it's really pronounced. This is where the Sierra Nevada are where you want the precipitation, because that's where your big reservoirs are to store all the water. But even on the coast, the north coast of California has been pretty dry. So the stream flows are down. There's not quite as much water to go around as you would want. So if considering just the Northern Sierra, there's a common index that's used. It's been around for a long time called the Northern Sierra 8-Station Index. So it's a grouping of stations that are, you can see, geographically dispersed across the Northern Sierra and the Shasta region. And we can look at, well, how does the precipitation over an area relate, over the long term? How does the current precipitation relate to what you expect over the long term? And this graph shows it starts from October goes through the end of the water year, the end of September. So we're currently right here. This is what we've gotten so far. We sort of had two storms this winter. We had one in December, and it shot us up here in this period. And then it didn't rain for quite a while. There was a long break. And then in early February, we shot up again. And then it just sort of, we've been getting little bits of precipitation, but no big atmospheric river events, since the one in February. This white area, lighter colored area outlined here is showing what's the average. So 50 inches for the average long term for those 8 stations. What did we get in 2013-14? It was pretty dry then. Last year too, only 31.3. Year before, 44.3. So we've had several years of below average. Nothing close to the driest on record there. And the highest we've ever seen is this 88.5 in the 1982-83 water year. There's a similar index, and so we're currently at 34.7. We're probably not going to see a whole lot of increase just because climatologically we're in that time of year where it doesn't rain much. although we've been getting some recently, but it hasn't added up too much. And that's the gap between current and average for this time of year. There's a similar index for the San Joaquin Basin. It's called the 5-station index. It's this grouping sort of in the central Sierra here. And they've done much worse down there, and precipitation-wise. We've had only 17.1 inches for this year. It's not that far from the driest on record. And if you look at last year was down there too. And the year before wasn't much better than that. So we've had several years of really dry conditions for the San Joaquin Basin. And you can see the gap is pretty big there. Normal of 40.8 inches, or the average is 40.8 inches. The biggest year they've ever had, 77.4 inches in that 1982-83 period. So we really want to look at, well, what's the cumulative deficit over time? How much has this been adding up to? If you look at for the last several years, around this time here in 2012 or so, we just sort of started losing ground. And we even though it's rained, precipitated, we haven't closed that gap for what you would normally get. So we have accumulated a deficit of over 40 inches in the Northern Sierra 8-station index. For the 5-station Central Sierra, the gap is really big. It's 70 inches. If you were to close this gap next year for both of these stations, for the Northern Sierra, you would need to have the 42 inches on top of the 50. And so you would look at about 90 inches, which is bigger than anything we've ever seen if you're going to close that precipitation gap. For the Central Sierra, 70 inches on top of the 40, you need 110 inches. And the highest we've ever seen down there was over 80 inches. So not likely that we're going to close this precipitation gap anytime soon in the Sierra. If you look at reservoir conditions back in the fall, they were looking pretty low. We were drawn down from the summer. We were at 24% of capacity for these big reservoirs, Shasta, Oroville up north. The reservoirs in the central southern Sierra were down, some of them down to 10%. We got a little better by January. We had rain in December, and right now we're currently sitting at Shasta. They're about half full for Shasta, Oroville, and Folsom. And they're not doing so well down in the central southern Sierra. Some of them are still, Exchequer is only at 11% of capacity. And as a percentage of normal, they're about anywhere from half to 3/4 for the northern Sierra, and for the central southern Sierra, they're at almost 20% for Exchequer, 35%. It's kind of variable as to what you would normally get. These reservoirs typically fill from snowmelt, which we'll talk about that in just a minute. But looking at, we have this very large reservoir, Shasta, 4.5 million acre feet, Northern California. It's what carries us over from that year-to-year variability. It stores a lot of water. And starting in October of 2011, we filled during the winter, got it up pretty full, and then we drew it way down. There wasn't a lot of precip, so it got drawn down by October of 2012. We had another winter of precip, and we ended up lower than we were the year before. Another big drawdown, lack of precip, and so we refilled it a little bit. And so it just kept coming down, 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 and then here we were in 2014. And this year, actually, we didn't get a lot of snow, but we had 2 big rainstorms, and so that actually put it up higher than it was at this time last year. So Shasta, we kind of bought some time with that one. The other reservoirs, they can only store so much, and they're reliant mostly on a lot of snowmelt recharge, especially as you go south in the Sierra. Well, what's our snow been? So this blue line shows our snowpack for the Northern Sierra, Central, Southern Sierra. The red there is showing what it was during our benchmark low year of 1977, and we're below that. Everybody saw the governor up there when they put the snow course measurement in, and at the media location, and it was just a dry field. Well, that means that there's no melt that's going to be coming into the reservoir. So even though the reservoirs are doing somewhat okay in some areas, they're not going to get much in the way of recharge. Our water supply forecast, looking out for the April to July period, across the area, they're generally 50%, but they are even ranged down for the southern Central Sierra, 10, 15%. So really low volume projections. If you look at, for the water year for Shasta, we're not so bad. We're above the record low for this time of year. And here's the variance that you might expect. We'll end up somewhere in here, probably close to there. So we're not too bad up at Shasta. Now, if you go down to Pine Flat in the southern Sierra, they're below the driest ever, and even the wettest projection doesn't get it much above that by the end of the water year. So we are looking at next year as kind of a critical year. If it's not wet, we might be in trouble. And they talk about, it's sort of a common sense thing, a drought ends in a really wet year, right? Well, obviously, right? I mean, it's kind of hard to imagine it just creeping along and gradually closing the gap over the years, given the variability that we experience. So that's how droughts have ended in the past. You have a really low point here in the mid-70s, and then we had a really wet year after that kind of brought the lake level back up. And another drought in the 90s, early 90s, and now we're in this period here where it's going to take quite a bit to bring it back up. Those are the kind of highlighting the drought periods of recent memory. But drought is more complicated than this precipitation deficit. And so we have issues of water supply or allocations being more than what is available. And people have rights to more water than we can actually deliver. And then groundwater's been under attack. It's been depleted over the years. So those two things could come to get us. And this is the Colorado River runoff and demands. Not all the water was used from the Colorado River for what people actually were entitled to. So we've gradually been on this. People have been using more and more water over the years, more and more of their share, and this has been the runoff, this actual supply, and these have finally crossed. They're probably not going back. So there's more demand than there is supply on the Colorado River system, which makes it sound like Lake Powell, Lake Mead are probably just going to keep dropping unless something changes significant. You look at an aquifer in the Pitt River, this is north up by the Sacramento system. That one's been coming down. This is a long-term graph that starts in, looks like 70s. If you go back that far, just, you can see the aquifer just dropping. This is a really volcanic type area, and it has pretty good, it just delivers water year round, even without precipitation. But that's getting drawn down. You look at the Central Valley, that Tulare Basin. You have these wet, dry year periods in here, and things bounce around a bit, but for the Tulare Basin, we just keep dropping. And the groundwater's getting depleted down there as they try to keep the farms going. So our drought's been brought about by these multi-year precipitation shortages. It's going to take a really wet year to kind of break the drought, maybe several wet years in this case. We started out the year last year with the last couple of years with really dry antecedent conditions, low reservoirs. We're going to start out next year that way too. And the issues to really think about are that what are we going to do when the groundwater runs out? How are we going to make up that gap? For the next drought, we're not going to have the groundwater. And what are we going to do about these water being more water rights than what is really available in an average year? The one question that didn't come up here that typically does is El Nino. Well, is El Nino going to bail us out? And now there's a moderate El Nino in place. There's a possibility of a strong El Nino next year. And if you hear that, really, El Nino doesn't help us much. A strong El Nino signal can give you a wetter than normal year in Southern California, But as we know, Southern California doesn't really get their water from Southern California. So El Nino's not gonna be our savior. Toastmaster.